All right, well, welcome everyone to this webcast on defending lift and shift cloud applications. So for those of you I haven't met before, my name's Ryan Nicholson, and for those I haven't met yet, I hope to meet you hopefully sooner than later. I guess that will all depend on how this virus plays out. But anyway, before we get started, you may have seen the term lift and shift, and it may have caught your eye, but for those that don't understand or know what I mean by lift and shift in this regard, that's what this Webcast is all about. It's simply when organizations move an application from one environment to another without stopping to redesign that application. So it's essentially that. Whatever I'm running on premise, I'm going to be running that in the cloud in this case. And that's a lot of the ways that organizations are initially, dipping their toes into the shallow end of the pool, if you will, for cloud, is moving those applications directly into the cloud as they are. But with that, there's going to be a lot of different challenges, specifically from the networking perspective, that we're losing, and I'm doing air quotes and you can't see them right now, that we're losing to some degree if we're not careful when we move these applications to the cloud. So that's what this talk is all about. What can we do as defenders to adequately prevent, detect, and I even have a module on responding to different threats that may be existing in these cloud environments. So here's what the agenda is going to look like. First, a really brief introduction on who I am, again, for those that I haven't run across or met before in my teachings with SANS or in my prior employment. Then there's going to be a section on moving to the cloud. It's more or less some boilerplate material on why some of the organizations are moving to the cloud today. If you were here a little early, you probably saw the SANS cloud curriculum, and that's something in SEC 488. Spoiler alert, I'm one of the co-authors for that, which I'll get to, that we do talk about in day one, is why is there such an interest in the cloud and why are folks moving there, which leads us as defenders to have to really adapt rather rapidly to protect these cloud workloads that are out there. I'm going to cover down a very simplistic case study, which in my experience is very, very common for those that are first moving into cloud, and it's going to be a public-facing web application. Now that's obviously not the end-all be-all when it comes to what I mean by cloud applications or cloud-based applications, but it's a good starting point to show the strengths and weaknesses that comes with cloud when you move these services out to a cloud provider. You may see on there like GCP, why is this guy talking about Google Cloud Platform? Well, nobody really does, to be quite honest, and a lot of the things that I'm going to be talking about do carry over to the other vendors as well. You get the big three, if you will, Amazon Web Services or AWS, Azure from Microsoft, and yes, I say Azure, not Azure, I'm not that fancy, and then Google Cloud Platform. A lot of the services I'm going to talk about, as I mentioned, they do have more or less in all three environments the same capability. It just might be named something ever so slightly differently, like packet mirroring versus traffic mirroring, things of that nature. But again, I like Google Cloud Platform personally. Nobody really talks about it, so I just decided to choose that as my vendor for my example. So I'm going to be talking through some of the services that can help us as defenders to help prevent, detect, and respond to these attacks to our workloads. Also going to cover down on a very unique technique that I fell in love with that I was using on premise before, but I had to think of a way to utilize this in the cloud. So it's awesome. I love that particular portion of my, not to discount the rest of this talk, but just hold on for that one. It's going to be some really awesome stuff using some tried and true techniques into the cloud space to further respond to some of the attacks that we may be seeing along the way. And of course, some slides on some concluding thoughts that I personally have as well. And then at the very end, of course, if you have any questions, there should be a questions area in your GoToWebinar where you can feel free to type those out. I probably won't be addressing them in real time, as I'm speaking. Let's say if I'm on slide 5 and a question pops in, that question's probably going to have to wait to be answered until the very end, but I will try to get to as many as I can, depending on how much time I have left at the end. All right. So first of all, who am I? As of very recently, I actually have the plaque on my wall. As of May 6th, 2020, I'm now a SANS certified instructor. So awesome stuff. It's my proudest achievement thus far in my career, to be quite honest. And that's putting it very mildly. I've got a master's degree. I don't want to harp on that too much. I've got loads of certifications, but among all else, I'm a SANS certified instructor. Very, very, very proud of that. It's a lot of hard work, and I'd like to think that it paid off. So I mentioned before, I'm also the co-author of SEC 488. Cloud Security Essentials, along with Kyle Dickinson. He's done a fantastic job with his material. I like to think I did as well. Brand new class for the cloud curriculum, and is really, if you're getting into cloud security via SANS, that's going to be your first step of your journey. Unless, of course, you're one of those very advanced cloud security professionals, you would probably want to jump into something at a 500 level course. But 488 is there for everyone that's either first timers into the cloud, or maybe they've been operating in the cloud to some degree, but want to learn a little more about cloud security and what you can do to further lock down the services and so on. My day job, I'm the SANS Senior Technical Advisor supporting the Blue Team operations side of the house. So yes, I write courseware for cloud. I primarily thus far has taught for the Blue Team, and I also support the Blue Team during my day job, which really amounts to anything Eric Conrad and Seth Meisner tell me to do, I will gladly do it. Anywhere from building data sets to building VMs to helping with lab testing, just all kinds of great stuff supporting the SANS Blue Team. Also a self-renowned certification junkie. I fell into a trap early on in my career, and I overcorrected that gap where I only got the certifications that were required of me to do my job, because otherwise I wouldn't have that job. It was a prerequisite for the position, so I got the certification and fell into that trap, as you see on the next bullet, many government employees tend to do. Just didn't really try to advance myself very much, but I realized that was a problem relatively quickly within a couple years, and just overcorrected and just went absolutely nuts with the certifications. And lastly, I put recovering government employee and contractor. That essentially means I was in the government, which I normally, most folks do this the complete opposite of how I do things, which if you get to know me, that's how I operate. I do things quite differently. But I joined the workforce as a government civilian directly, and then I became a contractor, and then I moved over to the private sector, which is typically the complete opposite of what most folks do. But with that came a lot of cloud experience. When I moved over to that contractor position, I was part of a very large cloud effort for DoD, which I'll have some of my examples coming up reflecting back on. And then lastly, of course, above all else, I'm a guitarist and musician. I've been doing that since I was 12 years old. I will never give that up. So you have to pry that guitar from my cold, dead hands. Other fellow guitarists will know what I mean. Okay, so anyway, that's enough about me. So let's get into the bulk of the material here. So moving to the cloud. Why are folks moving to the cloud? And what I mean by why are folks, why are our organizations demanding that we move to cloud? A lot of it is for these very reasons here. Most of these reasons, as you see, are for operations and maintenance purposes. Things like scalability, failover, very high uptime, so on and so forth. That's a lot of the cloud vendor promises that we more or less, for the most part, get when we move to a cloud environment. No longer do we have to maintain hardware, these big complex systems, when we can just simply click buttons and say go. You know, if my system ends up using too much CPU, spin up another one, things of that nature. It's very automated, very friendly to the operations and maintenance teams. But as you see very shortly, it's going to become very unfriendly to security teams, but there are some things we can do about this. So that's some of the reasons. Some of the other reasons are the pay for only what you need. That starts to perk up the ears of the CFOs, the chief financial officers in the organizations. Like, you mean I don't have to acquire this hardware every time I want to spin up a new server or things of that nature, right? I don't have to put in more and more effort and more funds into these efforts, when you could just simply pay for what you need from the cloud vendor. So that, not that you're not paying with the cloud vendor, but it tends to be, unless you're not careful, tends to be less put into, money put into these products in a lot of cases, into these applications. So again, with that though, the security team is gonna have their own challenges. And like I said earlier, lift and shift oftentimes when you're forced to move to the cloud is going to be, let's say I'm running 3 servers on premise. That essentially means in a lot of cases, I'm going to be running 3 servers in a virtual private cloud environment. So we'll talk through that. That's again, initially the initial steps that a lot of organizations are doing when they move into cloud, if their staff doesn't have that full cloud knowledge, to start utilizing some of the purpose-built services and things of that nature. So if they are starting to use some of these purpose-built services, as you will, as you can see on the slide here, there's a couple. The first one being with a web server, for example, if you're just simply hosting static content, right? You don't have to spin up an Apache instance inside of, like EC2, for example, in AWS. you could possibly host all of that in an S3 bucket and do an S3 public website. So that's a lot, that's even less to manage at this point. So you could do that, but just think about that from a security perspective. How am I getting logs off of this system now? What do the logs look like? What should I be paying attention to? Things of that nature. So when we're moving away from even lift and shift, the challenges just get ramped up that much further. And that's something in Sec 488 that we really deep dive into a lot of these use cases and what if type scenarios. And then if you are running dynamic code on your website, for example, again, you're not required to be running Apache with PHP, for example. You could potentially be running something like Lambda or something of that nature, right? Where you could dynamically process the user input, give them back some dynamic output in real time, a lot less to manage from an operating system on up perspective. Same thing goes with databases. There's a lot of managed database services out there to where just a few clicks of a button, you've got, boom, you've got a SQL server just stood up instantaneously. No more operating system to install and then having to install and configure a SQL application and manage the databases and things of that nature. It's more or less click a few buttons and then just you're responsible for managing that data itself. But when it comes down to attacks and things of that nature, they could be much more challenging to run down in a lot of cases, again, if we're not careful here. So it does save a lot on the operations side of the house, but starts to make the security team their job a little bit more difficult. And lastly, just throwing even more things into the mix here to consider, there's a lot of differences when it comes to on-premise network protection versus some cloud-provided services that can help us out in these cases. So as you see here, a lot of our examples are network load balancers, web application firewalls, layer 3 and 4 filtering, next-gen firewalls, and SIM all provide some level of security, whether it just simply being a bunch of logs that are generated, or they are legitimate protection and detection type services like a WAF or a next-gen firewall. So you have to begin thinking about, well, what's the equivalent in the cloud space that I can start to provision in my particular environment? Now, these are just, of course, some examples. I'm not just saying if you want to use a network load balancer, you must use AWS, because again, Azure, Google Cloud Platform, all the major cloud vendors are going to have this functionality. I just have a few examples that you could be using in particular environments, like a WAF, for example, which I will have dedicated slides on here because I'm talking about Google Cloud Platform. GCP Cloud Armor could be an alternative to that on-premise WAF solution. And then the other ones, as you can see there, like layer 3 and 4 filtering, Azure Network Security Groups, AWS Security Groups, the Google Cloud Platform, VPC Firewall, just some layer 3 and 4 filtering devices or capabilities we can put into these cloud environments, so on and so forth, as you can see listed here on the slide. So I'll move now into my case study. All right. I mentioned before that I won't answer questions, but I feel that I don't want to leave them hanging. Plus, I have that thing blinking in my face. So how about from data center to cloud? Possibly talking about some of those transitioning services between the data center, moving your data center workloads out to cloud and things of that nature. Again, that's not going to be the scope of this talk. It's primarily going to be if I'm going to be rebuilding something that's already existing in a data center or on-premise. So that may be what you're leading to here as well, where my definition of on-premise means in the like on-site or in a data center and then transitioning that workload out to the cloud. So hopefully I answered your question in some roundabout way. If not, please keep the questions coming. All right, so my simple case study here. So this is going to be very similar to what I saw when I was working that cloud contract for DoD, the U.S. Department of Defense. It was a cloud contract where we simply had a lot of customers that were transitioning from their on-premise, whether it being data center or on-site, those workloads, primarily web servers, right, over into cloud and into the cloud. So the cloud being, in our case, AWS, GovCloud, or Azure Government, but just simply moving from on-premise to cloud is simply what I saw an awful lot of. So a lot of it reigns true here with the following discussion. So here's my simple case study. This is our before picture. So you can see my art skills here. I didn't want to highlight try to draw out an entire network map, but this is very simplistically put. We have an attacker here on the internet, right? So this is my attack case study, if you will. They're coming through the internet in an on-premise environment or in a data center environment. Again, this is very simplistic. They're going to be coming through some sort of firewall, likely a next-gen firewall. So there's our first line of defense, right? That could be doing a number of things. If you've ever taken Sec 530, for example, which is the primary course that I teach now, we cover a lot of different capabilities that these next-gen firewalls could potentially be doing for us. Network antivirus, they could have built-in IPS, they could be doing IDS, your basic firewall rule sets, application detection, things of that nature, right? A whole host of things. We're getting visibility here in our on-premise environment. From there, if the traffic passes all the checks and balances, it would then have to go through another security device if we have an intrusion detection system deployed. And even so, these web servers that I have here, these could also be behind a web application firewall. They could also be behind, at the very least, some sort of reverse proxy that could have even more, at the very least, logging, but even more defensive capabilities involved here. So as you can see, there's a lot going on in regard to security, and this is, to be quite honest, how a lot of these setups are on in-premise environments. We're doing pretty well, I would say, as a community from the attackers coming inbound. Now, every time I say something like that, there's some humongous hack that happens the very next day or later in that day. But I can confidently say, for the most part, protecting things from a service side perspective, where the service itself is being attacked, we're doing an okay job. Now, don't get me started on phishing and client-side attacks, because that's not the scope of this talk either. But for on-premise, we're doing okay. But then when we transition to cloud, a lot of things change. Our attacker, again, sitting on the internet, but now so are our web servers. And if we're doing just simple lift and shift of that web server application, we're losing a lot of those things that we previously had inside of our network. Notice that the DMZ is no longer here. The attacker's going through the internet and just straight out to these, in this case, Google Cloud Platform, directly to our web servers in this case. Now, there's obviously a lot of best practices we can be putting into place here. But I'm thinking, again, from an operations and maintenance perspective, when people first move to cloud, they're going to have that mindset. Let's save some money. Let's have the maintenance be very, very low, best we can. So that you'll see something like this in these cloud environments, where we are utilizing one service here, HTTPS load balancer, right? This is in an effort to, again, add that elasticity to our cloud environment, to where if we have a very, very busy web service, right, we're consuming all the resources of one instance, for example, we can start to expand using instance groups here, right? So if we're being overwhelmed by network or by web server traffic, let's say we're TurboTax, right? I don't want to throw TurboTax under the bus or anything, but I can imagine this is how they would operate in the cloud. I don't know this for a fact, but let's just say tax season rolls around, that one web server they typically have running out in a cloud provider just isn't going to cut it anymore. So thinking from that operations and maintenance perspective, let's put in place an instance group where we slowly start expanding out our number of instances based upon how much traffic we're seeing or how busy those resources are. And as that starts to calm down, let's say May, June timeframe, who knows now, they keep, at least in the US, they keep delaying the tax requirements here, but nonetheless, as that traffic starts to slow down, that can start to shrink the number of servers we're running to save us money, things of that nature. So this, by definition, is not 100% lift and shift, but this is often what you'll see as things start to transition out the cloud. And security, again, the only thing that I see on here from a security perspective is this HTTPS load balancer. We at least have HTTPS coming into our environment. Right, but that's really it so far. Let's fix this coming through our cloud here, our cloud talk here. So let's talk about a threat scenario. Based upon that last diagram that I just showed, attackers could be coming at us for a number of different reasons. One, we're very, very targeted. Maybe we're a company that they would just love to get that juicy information from, right? Or we could be stumbled upon. That could be the other end of the spectrum here. We just have someone out scanning the internet and they happen to discover we have a weakness by some way, shape, or form, and they come at us. So these are the types of things that we should be on the lookout for in this particular scenario. Again, it's not a complete list by any means, but just for the sake of this webcast, I only have an hour. Let's talk about these in particular. The adversary could be launching some sort of web recon, looking for known vulnerable web pages. They could be looking for pages with authentication. Maybe that page in and of itself doesn't have a vulnerability per se, but it does allow like administrative login or something of that nature, some form of login to that particular website, which could then extend their reach into areas that they shouldn't be operating in, right? So if they discover those pages, they could launch tools like Hydra or SQL Map or something of that nature to try to break into this particular website. And as I mentioned, like SQL Map could be used again for other reasons too, like SQL injection, right? That's the primary purpose of that tool, or going after other open web application top 10 vulnerabilities, right? So if you're not familiar with OWASP, they every few years or so, they'll put out a brand new list, which doesn't change all too much other than they might reorder some things or regroup some vulnerabilities for web applications. Things like SQL injection, command injection, things of that nature that could potentially go wrong with a web application in and of itself may find its way on that list, and those should be the things that the web application developers are on the lookout for, trying to prevent. So attackers, of course, are going to be trying to take advantage of those types of vulnerabilities. So with that example that we had in place here, that example diagram, how do we even start detecting and responding to these threats at this point? Because if you think about it, the only real thing we have in place at this point is just that web service, web server itself. It's generating logs, but is that going to be good enough to adequately defend that web server? I personally don't think so. So, which leads me to the next question. Where are the logs related to this attack in this case? I mentioned before, we have the HTTPS load balancer. We might get some logs there. We have the web server itself. We may be generating some web application logs. If we see a bunch of failed logins, for example, we might see some 401 errors. If we see someone trying to discover some web pages and they're not there, we may see a number of 404 errors. But that's pretty much all we're going to see for the most part. Yes, we could do some, promiscuous packet sniffing on the web server itself, deploy a local IDS or a local network security monitoring tactic there. But there's better ways of doing this, in my opinion, which we'll see coming up here very shortly. We're also losing some of those awesome tools that we had on premise, at least for now. The WAF, for example, we don't have a WAF deployed. We don't have, we do have those reverse web proxy logs, as I saw. We do not have NSM at this time, again, unless we put it on the device itself or the instance group, those instances that are spun up. Also, and I didn't mention this on premise, a lot of techniques that the security teams are doing on premise are also capturing network flow. So we're potentially losing network flow because that's something you don't get out of the box with these vendors unless you subscribe to these services, which again, I will talk about very, very shortly. So you may be asking yourself some other questions. Can I place the same tools in this environment that I was running on premise? To a degree, you may be able to, but there's going to be some prerequisites for that, which I'll cover here shortly. And then can I automate a response to this attack? I think you know my answer to that as I was laying out the foundation of this, this webcast. I believe so, at least to some degree, as we'll see an example coming up shortly. Okay, so with that, that's kind of the gloom and doom section of this talk. So let's do something about it, because that simple lift and shift strategy from a security perspective is just simply not going to cut it, in my honest opinion. We're going to be missing a lot of things. So what can we do to further protect our workloads that are in the cloud, at least from a web server perspective? The first one is, as I already let the cat out of the bag here, our HTTPS load balancer that's in place, well, that's generating some awesome logs. It's terminating HTTPS sessions. It's generating logs for us. We just have to, of course, get those logs somewhere, move them somewhere, right? As I say here, shipping these logs off to a SIM or somewhere we can correlate our data to make our analysts happy. Because to be quite honest, digging through the cloud portals or the cloud consoles looking at logs is not my idea of fun. So we are generating these logs because, again, they're terminating these sessions. They're seeing that plain text, and they're generating some pretty nice logs for us. They're not complete, like we're not seeing the actual payload that's underneath in a lot of cases, but we are seeing the high level stuff, like there's 404 errors that are being responded back to. We're seeing like timestamps and very, very useful things, as I'll show on the very next slide coming up. And I do have a note here. If we went serverless, I mentioned what serverless was, just another reminder to say that if we were going serverless, we may have to look elsewhere. An example of a serverless application in AWS could be API gateway, which feeds Lambda, which pulls data out of a DynamoDB database, right? So there's 3 cloud services right there that are all being interacted with. We would have to figure out creative ways to pull logs from those services, or as those services are being interfaced with, how do we generate logs for these particular services? But from this lift and shift strategy, it's actually a little bit easier here because we have this HTTPS load balancer in front of everything. We've got that those access requests coming from our attacker, at least when it comes from HTTP, right? So here's what these logs actually look like in Google Cloud Platform. Again, very, very similar in the other vendors. You're going to get very similar information, and you could break these apart, as you can see with the arrow on the left there. But the reason I have DERB in the title there, if you're not familiar with the tool DERB, the way I use it at least is to try to discover web pages that just aren't advertised, right? Some sub pages, for example, or some subdirectories of this web server. Just see what's out there, right? Have a word list, a pretty robust word list, throw it at the server, and if it comes back with anything other than a 404, that page probably exists in some way, shape, or form. We're seeing that kind of attack right here just based on these HTTP logs. I would say that I'm pretty confident this is the type of attack if I didn't know that I ran this attack, right? If you look at the timestamps, I apologize if that's hard to read, but it starts at 7:28 and 37.159 seconds Eastern Daylight Time. We've got a number of requests here, all that I could fit on the slide at least. They all end within 0.7 seconds. This is not, to me, normal user traffic on this particular website, to be quite honest. Plus, you can see the URIs that are being accessed, like XML, XML-RPC, XSL, XSQL, so on and so forth. Looks to me like this would be some sort of dictionary attack against my web server, so some things stick out. I thought this was pretty interesting too. By default, DERB chooses its user agent as IE6. Just thought that was kind of comical. Not to say if you see IE6, someone's scanning you with DERB. That could likely be the case though. There's not too many people using this guy anymore, so just throwing that out there. But with these logs, these can be very, very powerful for us to start to get that early warning system of some attacks that are coming our way. What else though? So I talked about that's primarily obviously going to be web-based attacks, but what about everything else? What if they discover this system, but they start coming at us against other ports, other protocols? What if they do compromise the website and these those HTTPS proxy logs just aren't good enough to determine that that is in fact an exploit or an attack that was successful? What other things can we be looking for? Well, flow, which again is not on by default, but you can simply turn that on as well to capture. If you're unfamiliar with flow data, you get a lot of great layer 3, layer 4 type information here. Who's the sending source address? Who's the server on the other end? What ports were used? How many bytes were sent between the two? When did this flow start? When did it end? So you start to pick out some oddities in your environment in this case. You get a sense, you first have to get that sense of what normal looks like, of course, right? If you've been to any SANS cyber defense class, normally on day one, they're like, know thy network. That's normally one of the first slides. That's especially true here. You start to understand what normal flow looks like in your cloud environment, and you can start to pick out those anomalies. If all of a sudden your web server is talking out on port 444 TCP, that's very, very strange, right? That's not normal. So you start to pick out some of those oddities and start to investigate what's going on here. One thing of note though, well, a couple things that go hand in hand here. There's this concept of what type of flow log is this? There's different flow log types, bidirectional and unidirectional. Now with GCP and AWS, I'm certain they use what's called unidirectional flow logs. Let me first describe what bidirectional means, and this is probably what you're more familiar with when you're looking at flow data. This is essentially the entire flow between two hosts. It's all captured in one record. So if I initiate a connection to a server, I will show up as the source IP, the server will show up as the destination IP, the server's well-known port in most cases will be the destination port, so on and so forth. That's one log. Until our connection is over, we'll generate that flow log, and it's just one log for our entire communication over that port and protocol. Unidirectional, however, is a bit different, and putting my analyst hat on, I'm definitely not a fan of these, but it's better than nothing, to be quite honest. With unidirectional, when I send, all the data I send from myself to the server is captured in one record. Everything coming from the server back to me is going to be in another flow record. So that can be a little confusing to run down. And to add insult to injury, the returning traffic, if you look at the data in the flow record, it's going to say source IP address. It will actually be the server. So it'll look like, for example, the server is making a connection back to me when that, in fact, is just that return traffic coming back. So that can be a little confusing to the analyst. They have to look for that companion record, if you will, to determine who the real source is in this case. But again, it's better than nothing here. So here's an example, and I glossed over some of the bullet points on the last slide because flow data can cost a good bit of money, especially if you have very busy VPCs. So you can imagine you have to pay to store all of this data. So if you're traversing 40 gigs of data inside your VPC a day, right, and you're trying to capture all of that flow data. Now, it's not going to, of course, be 40 gigs of data because it's just metadata about the network, but it's going to be a significant amount of data. You have to store that. So I broke this into two sections here because if you turn off what's called the additional metadata in Google Cloud Platform, you can cut down the amount of data you store. The other method is to sample your flow data, which I'm honestly not a fan of, because if you sample your data, you could be missing some things. It could just be that one connection that is in fact malicious. You could be missing that because that wasn't part of your sample, if you will. So this is what the typical flow data looks like when you don't turn on the additional metadata. And I think this is fine for most use cases. I'll show you that on the next slide, what that additional metadata looks like that you may or may not feel to be useful in your particular environment. But you get the heavy hitters here: the destination IPs and port, the source IPs and port, what protocol number is being used. So for those that are unaware, protocol 6 is TCP, right? So that's a TCP connection. And this just showcases my the pain point of those unidirectional flow logs, because if you look closely, the source IP and port looks like someone's connecting using port 22 to some ephemeral port. Well, this is actually the return traffic coming back from something running SSH. And I happen to know this because I generated this traffic. But otherwise, you'd have to dig through other logs and look for that companion record, look at timestamps to see which order this all came in and things of that nature. So it can get a little tricky to analyze. So this is what that additional metadata looks like as well here. So as you can see, you get some cloud specific information, like which instance did this actually, is this attributed to in this case? Like what's the VM name? What zone was this VM in? And you gotta love the project IDs that are just randomly generated by Google. It reminds me of Docker and how they just come up with very clever words in their word list. Like my project ID in this example is Angular Polygon 273914. And I just think that's pretty neat, right? It's cool stuff. It's better than just a bunch of hex numbers, right, that you see in some other providers of project IDs. You also see what region that lives in, so on and so forth. You also get some VPC information about the VPC itself. Nothing fancy here. You know, I just use my default VPC, so nothing really to see here. And just ignore that start time. That's still in that other piece as well. But the way I split this up for the screenshots, it didn't fit properly. So just ignore the start time. That's going to be in every record. So you get to see the start and the end time without having to see the additional metadata. So again, it's up to you. If you can store the data, it's not such a burden cost-wise. Probably doesn't hurt to save. If you find no use for it whatsoever, feel free to not bother with it. All right, so moving on even deeper into the inspection here, because we were getting just the HTTP data, then we were getting just the flow data. I want to start seeing payloads now. I want to see what's actually traversing in this payload itself. So how do I do this in the cloud? So I'm going to talk through some network security monitoring, again in GCP, but also these techniques work in AWS and Azure pretty much the same way. Again, they just may be naming these services ever so slightly different, right? But they're pretty intuitive on which one you're going to be searching for. If not, I've found Google to be my friend in a lot of cases here. What's the comparable service to X? And they'll normally show you the comparable service in that other vendor if you're forced to work in another vendor, with another vendor. So before we do this fancy IDS stuff that I'm going to be talking about when I get into my automated response type of capability here, we have to first come up with a way to see this traffic. So we need to get that true network visibility. I should put air quotes in true because it's still not absolutely everything that we're going to be seeing here with packet mirroring, but it gives us the majority of what we need. I'll just leave it at that. It's not absolutely everything, but it's the most we can get at this time. So the first service I'm going to talk about is GCP packet mirroring here. This simply clones the traffic from a single instance or a set of instances or every instance in your VPC and sends that to another instance group, in this case, another group of instances. So there's a couple prerequisites that I find out the hard way typically when I'm starting to explore some of these services, to where you'll be digging into a service, you get most of the way configured through it, and it's like, oh, nope, you forgot to set this thing up, try again. So I'd laid this out here for your sake as well. If you try to stand up packet mirroring, you need to have a mirror source, which, as I mentioned, can be an instance or it can be subnets as well. And in our case here, these will be the web servers that we're trying to protect. You have to come up with a collector destination, which in this case, and again, found out the hard way, this needs to be an instance group, not a single instance. So, which can benefit the security team here as well, because if if we have a lot of traffic going on and we undersize our instance, for example, let's say we're going to put Suricata or Zeek or something of that nature on an instance, but we find that we're starting to overload the system. If we have an instance group instead, now we could start to do those cool elastic things that we were doing with the web server with our NSM devices here. If we start to expand, we have 2, 3, 4 servers more or less on the fly here, and handle that additional data and then scale that back down as the network calms down. Let's say we're busy 8 hours of the day, but then the other 16 hours aren't so busy. We can spin that down, save some money in the process, and not lose data, more importantly. And then there's also filtering. So you can filter based on protocols or IPs. The protocols, however, are limited to just TCP, UDP, and ICMP, which honestly is the majority of your traffic, but just be aware it's not everything. We ultimately do want it all, we just can't get it all, at least at the time of this writing. So I did have a problem though, and I don't want to call out any one vendor, but I will. GCP with their packet mirroring, I found out the hard way, again, you got to find out the hard way and it sticks with you, that proxy traffic that was headed to our instances, for whatever reason, because they do advertise that anything coming into or out of instances will be mirrored, but that traffic was not. Anything coming from the HTTPS proxy to the web instance was not mirrored. So the collector in this example never sees the GET requests, but it did see the 401s coming back. So the return traffic back to the HTTPS proxy was mirrored, but the traffic coming in wasn't. It just blows my mind why that's the case. I have no idea why to this day. So if you work for Google and you're on the line here, or you see this later on, this webcast, and you work at Google, throw me a bone here. I couldn't figure this one out. I had to do something like this. I had to do some fancy stuff with IP tables. That's really as far as I want to go with this. I want to sum this up very basically. So I had 2 web servers running in my web server instance group. Let's call them web server A and web server B. If web server A received the traffic from the HTTPS proxy, that's why there's subnets are listed there. Those are the known Google Cloud Platform HTTPS proxy space that these things would be seeing. If it receives that traffic, it will forward that traffic over to web server B, because now I have traffic, I'm mirroring my own traffic at this point. I have traffic going from web server A to web server B. It's no longer coming directly from the HTTPS load balancer. So it will be mirrored and sent further on down the line to my IDS. It was a really hokey workaround. If I'm doing flow logging here as well, I'm generating basically duplicate data. It's not the most efficient thing in the world, and I will come out and say that, but that's the only way I was able to find that I was able to grab that initial traffic coming from the HTTPS proxy. But hopefully there is a fix for that, or maybe I was doing something wrong, who knows. I did a cool exercise in IP tables routing, right, if anything. Okay, so that was a lot of detection talk. I'm going to move in very briefly to prevention, and then I'm going to wrap up with some active response type stuff here. But first, I want to cover our gap that we had previously. There was no WAF when we moved into the cloud. Well, there is a WAF service, GCP Cloud Armor, that we could put into place. We could do very basic blocks like IP addresses, specific request methods, all the way down to the payloads that are coming in as well. Cloud Armor does integrate with the HTTPS proxy, so it does see the plain text data. So that's awesome. We can start to, we can even go down to like, if this is an authentication page and we only expect a username to have lowercase characters in it, we can set up a rule to basically say, only allow this post variable of username to have lowercase characters using regex, of course. If you see anything else, block it. You get very, very granular with these Cloud Armor rules here. That way the data never gets to the web server instance. But just be aware, it's not going to prevent every single exploit, as you can imagine. There's also some rule sets that you can pull in, which again aren't perfect, but they're a good start. They're from OWASP. They're part of the mod security core rule set. Cloud Armor, you can pull in just right at the get-go. You can have your first 2 rules being block anything that's considered cross-site scripting and anything that's SQL injection. Again, those aren't going to be all inclusive. There may be some fancier SQL injection that does squeak by that we have to account for in our other rules. And I have an example of something like that coming up here. A simple rule set that you may see. As you can see, my web server is very, very simple. The 3 allow rules, after you've passed the SQL injection and the cross-site scripting rule, right? I want to put those at the top. Then you can access my home page. And I have 2 there because you may be trying to access index.html for whatever reason. So my home page, and you can get to the admin.php page. Other than that, go away. So very, very powerful rule set. So that crawling attack that we saw earlier, where they're trying to crawl through all the non-existent web pages, now would be knocked down by Cloud Armor. It will never get to my web server with this rule set. At least that's my belief. And I did test with this, and it worked very, very well. I was only able to see those 2 pages on my web server. Of course, your web servers are going to vary greatly depending on what files exist and things of that nature. All right. So the last bit I want to dig into here before I conclude is the bring your own response. I'm very excited about this section. So this is, yet again, we can do better at this point. We've got some prevention using Cloud Armor. We've got a lot more logging than we had before. We've got some network detection, NSM type detection now, but let's do something about it. Once we see these things, let's automate some kind of response. And a lot of your cloud vendors will have software development kits like AWS CLI or the Azure CLI and G-Cloud in this example to talk directly to services. So if we can integrate those types of software development kits into our security products, we can have the security product now talk to the cloud service provider and say, hey, modify Cloud Armor, for example, to block this IP. They're doing nasty things. Or add this rule to the VPC firewall. This IP is doing some very strange things. And I'll cover an example on how we can do that. But first, I got to talk about Zeek. I have a newfound love for Zeek because I recently, and it took me way too long to do this, I recently took Sec 503. Very late in my career, in my opinion. I should have taken this years and years and years ago. I learned so much. I thought I knew a lot coming into this. Man, was I wrong. But Sec 503 and Sec 530 has a little bit of Zeek material in it that basically tells me the way I've been using Zeek, I've been doing it wrong. Generating logs is not the end of Zeek. Yes, it does create a lot of great metadata, like flow-like data for us, at least about the protocol or protocol logs, if you will, but it can do so much more using Zeek scripting because you're already getting a lot of very useful data. And if you learn how to script with Zeek, you can make Zeek do other things other than just create logs. And in this case, I'm going to have Zeek look at the traffic headed to the web server and make a decision. And in this example, I have it looking for 10 or more 400 errors, if you will. I'm just going to shorthand that within 60 seconds from the same host. So if you're scanning me or you're launching an authentication attack against me, Zeek's going to see that. And then if it does see that, it's going to use G-Cloud commands to add firewall rules and Armor rules to block you for X amount of minutes. Now, this is very flexible. It's using their catch and release framework. The reason why I chose catch and release, instead of just adding the rule and leaving it there to live forever, those rule sets, especially with public web servers, can get very, very, very large, and they become very, very inefficient. Because you can imagine every legitimate request to your website will have to go through possibly thousands of block rules before it hits that permit rule. With catch and release, with Zeek, you can add a block, and if the attacker stops, remove the block. It doesn't need to be there anymore. And if they start attacking you again, add the block again. Just make that block longer. That's why I have 15 plus minutes there, because it'll watch the attacker's IP as well. So if they don't go away after the 15 minutes, you can add that as well. I have a Zeek question, perfect timing. How do you prevent Zeek to be fooled if an attacker spoofs its source IP leveraging the X-forwarded4 header? Now, that's a good question because that X-forwarded4 header is being added by the proxy that we are running. So they would somehow have to, and I'm stumbling here because I'm not sure how that would actually work, because as those requests are coming in to our HTTPS proxy, our HTTPS proxy is adding that IP address to the X-forwarded4 header. Now, you may have multiple in there because if they're coming through a proxy, for example, or they're adding that header themselves, your X-forwarded4 proxy will have more than one IP in it. But ultimately, the IP that the HTTPS proxy sees, that one will be leveraged by Zeek, and that will be the one that's blocked. So I'm not sure how an attacker could evade that, but I could be wrong, right? If I'm wrong, please reach out and let me know, and I could definitely make this this script even more fully featured here for that particular use case. Great question, fantastic question. Okay, so really quickly, that was Zeek in one slide, right? And there's a lot more I can expound upon there with Zeek, but I'll leave it at that. Just saying that Zeek can look for suspicious behavior that I scripted out, of course, and then take action using G-Cloud commands to add blocks. So again, this is before. This is what our environment looked like beforehand, and this is now. We've added a lot more services, to be quite honest. We are, of course, going to make the CFO slightly less happy because they thought moving to the cloud would save them a ton of money. Well, they're going to save a little less money potentially here. We have our load balancer as we did before, but now we have Cloud Armor. So when they're attacking our web server, for example, they first have to get through Cloud Armor. So if you remember that rule set, okay, admin.php, that very basic rule set, totally fine, no big deal. So they'll get through Cloud Armor, they'll go through our HTTPS load balancer, and then hit our web server instance group. But as they're coming into this instance group, that's also being viewed by our IDS sensor. So if they do start attacking that admin.php page, we'll catch on to that because Zeek can see this now. And then with that script, put in blocks in a couple places, first at Cloud Armor and at the firewall. Well, why both? Because they might, not try to attack us via the web anymore. They may try to attack, maybe we have a DNS server, an external DNS server that sits in here as well, or some other service that's not web fronted by Cloud Armor and the HTTPS load balancer. I just want them to go away completely. You're attacking my web server. I don't want you accessing my environment at all. Right, so I put it in both places. Okay, so I tested this out. I ran Hydra against it, trying to do an authentication attack. Don't try to attack that site, it doesn't exist anymore. So nsm.ryanick.com does not exist anymore. I ran the raw keyword list against it. And I also was watching the net control catch and release log that Zeek would, typically that would be where it ends, but I added that script to not only detect these attacks, but run commands as well to interact with GCP and knock down these connections. And as you can see, it looks like it worked. I have Zeek adding this rule set in place here. Again, the denies above the allows. So that's why I started my allow list at 1,000. If you're adding loads and loads and loads of these IPs, because you're getting scanned all the time, you may want to start your allow numbers a bit higher, because as soon as I would hit 1,000 blocks, my denies would start happening after my allows, which is of course not my intent here, because they simply won't be blocked at this point. So it added the rule there for me. It also added a rule in the GCP firewall, again, very early on. The reason why you see these X's in here, the name of the rules, I like to name the rules just so I can look at it and see, oh, Zeek blocked this, but it doesn't allow dots for whatever reason. That's not an allowed character of a firewall rule name, so I put X's in place instead. So you can see it in action there. Zeek took it upon itself to say, hey, this IP is doing nasty things, let's block it. And to add insult to injury. So by default, and this is totally configurable with Hydra, by the way, but by default, Hydra simply looks for 401 errors. If it sees a 401 come back from a web-based authentication scan, say, nope, didn't work. If it sees anything else, it's gonna say, hey, that's a valid login. So as you can see here, I fooled my little kid here. Look at all the creds. Looks like we have a lot of good logins, at least the way we're running Hydra by default. Now, of course, you can tell Hydra only look for 200s. If I see a 200 come back, an HTTP OK, for example, I must have logged in successfully. So that is totally, there's a workaround for that for the attackers, but at least throws them off their game a little bit. It's like, what's going on? Is my tool broke? They may be asking some very strange questions of themselves or their tools or our environment. They might think they're hitting a honeypot, for example, when it's really our production system. Okay, so that's really all. I did save a few minutes for some concluding thoughts here. Dominic has an awesome question coming up, but I want to get through my concluding thoughts really quickly, and then I'll open it up for any more questions that you may have. So in conclusion, we're as limited as we choose to be. That's the whole reason I put this talk together. There's a lot of defenders that I personally work with that just accept defeat way too easily. It's like, oh, we're in the cloud now. I guess I lose all my security. I can't see anything. Well, honestly, that's not the case based upon the couple dozen slides that I threw together for you. And it doesn't stop there. As I mentioned before, Sec 488 really goes into depth a lot more in a lot of different avenues here, a lot of different services that we're working with. So there's a lot of capability that the cloud vendor does allow us to do. We just have to do it because it's not on by default. And of course, if the solution does not exist to make it so, I'm a huge proponent of, if a tool doesn't do the thing that I want it to do, make it yourself. You'll hear me teach Sec 530, and I'll say it multiple times throughout the course. Any former students of mine in the room can attest to this. I make it a point that at least once a day I say, learn scripting, learn scripting, learn scripting. Learn Python, learn PowerShell, because you're going to come across a situation somewhere down the line where a tool doesn't exist. And if you have that tool in your tool belt, if you will, you can build the tool to do that thing that you want to do. Like with Zeek, for example, I had to learn Zeek because I wanted Zeek to be able to handle these things for me. I didn't want to have to buy another vendor product, for example, to do these automated blocks for me. If Zeek can do it, have Zeek do it, right? And as you saw earlier, we do need more in-depth monitoring in the cloud because what you get by default just is not going to do your analysts justice. They're going to have one heck of a time trying to run down an attack if they even see the attack at all. We have to set them up for success. That's former blue team analyst training guy coming out here. Part of my job before the government was training analysts, so that comes out as well. And if you want to build the exact environment that I played around with, I do have a Terraform template. If you're familiar with Terraform, and there are some steps on that GitHub as well if you're not familiar with Terraform on how to set that up. So feel free to use that if you want to play around with this. Google Cloud Platform does provide a free tier, but come to find out, since I wrote this talk, the WAF rules, the Cloud Armor rules, you have what are called service quotas. The number of rules you're allowed to have in the free tier is a whopping 0. So I found that out the hard way when I was trying to run through this again before my talk, that can't use Cloud Armor unless you have a full paid account, which is kind of surprised me. Again, if it's something I'm doing wrong, please let me know, but that's just something I discovered over the last week or so. Okay, of course, the want more slide, the SANS sales pitch here. I'm not gonna say what class to take at all. I might have a vested interest in one, but take one of these classes if you want to learn more about what I talked about here today. So I will get to, and so this is the last slide. If you want to get in contact with me, feel free to take a screenshot of this or write this down very rapidly here because this webcast is going to end in about 9 minutes. That's how you can reach out to me. Hopefully you enjoyed this talk. Got a couple questions from Dominic, and anyone else, feel free to start typing in questions. I'll answer them as I get them until I hit my time limit here, or if there's no questions left. So can you detect a password spray attack, horizontal brute force attack, or horizontal brute force using Zeek? I will say yes, but not the way that I scripted it. My script is focusing primarily on the source IP that's attacking a particular web server or group of web servers. You can modify that script to say if the targets, I want to pay attention to the targets themselves. If I see these targets being attacked by a host of IP addresses, I can collect those IP addresses and then block all of those IPs. But you will potentially knock down some valid connection attempts. If someone fails to log in during that password spray attack, you'll be blocking their IP as well. So just be aware of that. There could be a negative consequence, but they'll be knocked down for about 15 minutes or so. Okay. Also, if I understand well, WAF in cloud provided by providers are not the same features protections level that the on-premise one, right? I agree. What I showed you was about the extent of again, this is just me playing with Google Cloud Platform and their Cloud Armor. That's about the extent of it when it comes to their WAF. It's very much up to you. You were given basically a white screen, like here, insert rule here. Do you want it to be a very complex rule or a not so complex rule like blocking an IP address? And they kind of leave it up to you, where you're just looking at some, post variables or, IP addresses or methods and a combination of these things as well. It's other than the OWASP rule sets, it's just out of the box. You can figure it yourself. You don't get a lot of the like vendor supported rule sets that you get, those turnkey solutions, if you will, which, I have my own thoughts on turnkey solutions, but you don't get a lot of those vendor provided rule sets that you would in a cloud provider. Jose says, what about SSL inspection? Is there a solution from the cloud providers? Not to my knowledge directly from the cloud providers. So I was doing, in a way, I was doing that here because what I failed to mention, that HTTPS proxy, it's terminating the HTTPS there, and everything being sent from my HTTPS proxy to my instance within GCP was clear text. It was the port 80 traffic. So I was doing SSL inspection more or less by accident, but if I was re-encrypting that before it went back to my web server, I would have to get in the middle of that somewhere, right? If I can do out of band break and inspect, for example, if I'm using some weaker cipher suites, to be quite honest, I could do that. Or I would have to have my own web proxy in the middle of this, or my own break and inspect device or instance in the middle of this traffic as well, which kind of gets thrown in the face of all things cloud because you're adding another choke point, which cloud tends to get away from. Okay, for Mr. Khan, I believe we have Should systems moving from DC to data center to AWS review the AWS security controls to check which are being inherited and which are our responsibilities? Oh, you brought up that nasty word, inherited. That was some work that I did for the government, because we provided some support for some mission partners. Like, what do we inherit from you? You know, what security are you doing for us? That is honestly some of the same questions you need to be consulting AWS with. They have a lot of great documentation on here's what we provide, here's your responsibilities. And to be quite honest, your responsibilities are a lot larger than you think when it comes to security. A lot of it is on you. You may hear things like, you know, AWS gets a bad rap for those public-facing S3 buckets, right? That's not Amazon's fault. That's the customer's fault. Amazon gives you tons of capability to lock that stuff down, but it's up to the customer to fully inherit all of the security here, right? I knew you would remind me of some past work. Thanks. Awesome. Okay, I'm not seeing any more questions. So I think that's all I have for now. I'll give you back 4.5 minutes or so. And thanks, Yossi, for the comment. Really good session. I agree. So with that, that's all I really have. I don't know if the organizers wanted to say anything else or if we'll just end it here.